There are no blue tiger, no blue bat, no blue squirrel or blue ducks, even blue whale aren't that blue. Animals come in pretty much every color, but blue seems to be rarest. What's cool, though, is when we do fly a blue animal, they're awesome looking. Nature doesn't know halfway with blue. To understand why this is, we honor journey through evolution, chemistry, and some very cool physics. But first, we're gonna need to understand why animals are any color at all. And to do that, we need to go look at some butterfly because butterflies are awesome. And if you don't think so, you're wrong. This is Bob Robbins, he's curator of Leopard at the National Museum of Natural History, Washington, D.C. Butterflies are awesome. Make no mistake about it. They are a group of moths that evolved to be active during the day, and if you are active during the day, you have an advantage. You can use light to communicate. You probably realize this, but out of insect, butterflies display the brightest and most detailed pattern. There's no good reason for that. The color in butterfly wing delivers message. Alive, I'm toxic, and my mate, I'm male. And this is a terror, but not all butterfly colors are created equal. If we zoom away in our butterfly wing, we see the colors come from tiny scale. It's actually now mouse and butterfly get their scientific name. Orange, red, yellow, brown, the scale all contain pigment, organic molecules that absorb every color except what we see. Black scale absorb all colors. Animals from butterfly to birds to you and me don't make this pigment from scratch. They are made from ingredients in our diet. You might know this thanks to flamingo. They are born gray but turn pink thanks to pigment called carotenoids. In question they eat. When it comes to these colors, you are what you eat. But not so for blue. Blue is different. If you move the camera, you can see that color changes that you move the camera. It does. It's like the hologram thing. This is because there is no blue pigment in these butterflies. Wait. So they are blue, but they are not really blue. That's correct. Yes. You are lying to me, butterfly. There are blue morpho butterfly, maybe the prettiest butterfly of all. I mean, they did make it butterfly emoji. The blue color isn't from a pigment. The blue comes from the shape of the wing screen itself. And when I learned how this works, it kinda blew my mind. If we zoom way in on a blue wing scale, we see this little this. If we slide across the screen and look closer, we see the wrist rather shaped like tiny Christmas tree. The arrangement of the branches is what gives morpho wings their blue color. When light comes in, some bounces off the top surface, but some light passes into the layer and reflects off the bottom surface. For most colors of light, waves reflect from the top and bottom will be out of phase. They will be cancelled. They will be cancelled down, and that light is removed. But blue light has thus the right wavelength. The reflected light waves are in sync, and that color makes it to our eyes. The hole of mirrors only lets blue light escape. There is even a pigment at the base that absorbs the red and green light to make the blue even more poor. That's how we get this awesome iridescent blue. The microstructure of the swing itself. All of this happens because of the way light bends when it's moved from air into another material. So if we fill all those tiny gaps with something other than air, like alcohol, the blue disappears. Technically, this changes the index of refraction, but in plain English that means blue light is no longer bent the right way. The microscopic light filter is broken until the alcohol evaporates and the color returns. But these butterflies live in the rainforest. Do you think they lost their color anytime they got wet, right? Well, watch this. Wow, watch this. These wing scales are made of a material that's natural water resistant. What about this blue jay feather? What about this blue jay feather? If we look through it, the color completely disappears. No blue pigment. Each feather bristle contains like scattering microscopic beds space, so everything but blue light is cancelled out. Unlike the highly ordered structures and we find in butterfly wings, these feather structures are more messy like a form. So instead of changing as we move, the color more even from every direction. Peacock frill feather. Again, it's the shape of the feather, not pigment. But the light irregular structure are more ordered, like a crystal, so it's brighter from certain angles. There's even a monkey. Wow, let's keep this busy. Even that color is made by the adding and subtracting of light waves, thanks to structure in the skin, not pigment. And yes, even your blue eye, your color by structure, not pigments. Outside the ocean, almost exclusively the blues living things make their color with microscopic structure, and each one a little different. No vertebrate, not a single bird or mammal or reptile that we know of makes the blue pigment on its body. In fact, there is only one snow butterfly has the code of making a true blue pigment. But as the pigment in nature is incredibly rare. But there are not one exception so far that we know about. And these are over here called the olive wings. They have almost a blue pigment. They are not very common, and we don't know much about them. And I don't know of any other blue pigment. That's a really special butterfly. Why is almost all natural blue made from structure and not pigment like everything else? We asked this question to several scientists that study color, and here their past theories so far. At some point way back in time, bird and butterfly involve the ability to see blue light, but they hadn't yet evolved a way to paint their body that color. But if they could either be like going from early petrol to cities, peppers, beetles. It means new opportunity for communicating and survival. Creating some blue pigment out of the blue would have required inventing new chemistry, and there was no way to just adapt recept to their reasons. It was much easier for evolution to change the shape of their body ever so slightly at the most microscopic level to create blue using physics instead. They solve a biology problem with energy. What I love about this is this color has fascinated curious people for hundreds of years. After looking at peacock feather through one of the first microscopes back in the 1600s, Robert Hooke wrote, "These colors are only fantastic ones." Even Isaac Newton noticed that there was something unusual about this blue, and scientists haven't been studying it ever since. Not only because the science is interesting, but because it's beautiful. Thanks for watching and stay curious.